In this video, you're going to learn how to set up HTTP endpoints for updating resources. Together, we'll focus on updating a user, and in the next video, it'll be your challenge to update a task. So down below, at the end of our 3 user-related endpoints, we're going to go ahead and add a 4th right here. This will be using app.patch, the patch HTTP method, which is designed for updating an existing resource. So right here, we'll set up the path for this particular endpoint. That's going to be the same as what we have above. So here we are trying to get an individual user by its ID. Down below, we are trying to update an individual user by its ID. So that would be /users /:ID. Then we'll set up our async function. So right here, async, we'll set up the 2 arguments, request and response. Then we'll go ahead and finish off the syntax for the arrow function. Now, the first thing we're going to do inside of here is set up that try-catch block, and we're going to attempt to update the user with the provided ID. Let's go ahead and set the try-catch block up. So we try to do something, update a user by its ID, and if that doesn't go well, we will get the error in the catch block down below. Now, for the catch block, what we're going to do is hold off for the moment, and we'll go ahead and start with try. Now, the Mongoose method we're going to use to get this done is available in that queries list we've been looking at. Right here up top on the queries guide, we have find by ID and update. Now, we have other update methods as well, such as find one and update, update and update many, though we'll be sticking with this one, though technically you could get the job done with any of those 4. Let's go ahead and get started over inside of the try block right here. What we're going to get back from find by ID and update is going to be the user. So const user equals. We'll go ahead and use await to await the promise that comes back from user.find by ID and update. Perfect. Now, the first argument we'll pass in is the ID of the user we're attempting to update, and we already know where we can access that. That is request.params.id. This is exactly what we did up above for getting the ID for the user we were trying to read. Then down below, the next argument is the updates we're trying to make. Now, unlike with the MongoDB native driver, there's no need to use anything like the set operator. Mongoose handles all of that for us, another great reason to actually use the tool. So right here, all we have to do is provide the object with the various fields we want to update. So if I wanted to update the name, I could set name equal to some new string like Jessica. Now, in this case, we don't want to have a static update where we always update the user to the same thing. What we want to do is take the updates in as the request body. So much like we did for creating a user, the data will be passed through via the HTTP request. So right here, we're going to access request.body excellent. This is exactly what we did up just a little bit in the code when we originally created the user. Now back down below in the patch route, we can go ahead and provide the 3rd argument, which is an options object. And here we are going to set up a couple of options to get things working the way we want them. The first option is new, and we'll be setting new equal to true. This is going to return the new user as opposed to the existing one that was found before the update. So right here, we'll have back the latest data, the original user with the updates applied. Next up, the second option we're going to set is run validators. This is going to make sure that we do run validation for the update. So if I try to update my name to something non-existent, I want to make sure that fails. Anytime we're allowing the user to write data to the database, we want to make sure we validate it so that it comes in the format we're expecting. Now, right here, there are a couple of different things that could happen. 1, the update went well. 2, the update went poorly. And 3, there was no user to update with that ID. And we want to make sure that we handle all 3. First up, if there was no user with that ID, there will be no value right here. So if there is no user, What are we going to go ahead and do? Well, we'll be sending back a 404. So I'll use return to stop the function execution, and I'll use response.status to set a 404, and finally I'll use send to actually send it back. Now if the code down below right here runs, that means everything went well. I can stick with the 200 status code, which is the default value. All I'll do is use response.send to send the user data back. So if someone updates the user, we want to send them back the current user data. That would be all of the existing data with their updates applied. Now the next case is down below in catch. This is going to run if something goes wrong. Now this could be one of two things. It's possible that we have an error like the other ones we've talked about where we want to send back a 500 because we weren't able to connect to the database or something along those lines, a server-related issue. It's also possible that it's a validation-related issue, where someone has tried to update their name and they've tried to set it equal to an empty string as an example, which would not be valid based off of the model we set up for a user. For the moment, we're not going to worry about handling both cases. We'll just focus on handling validation. So that would be response.status, and we'll send back a 400. This is exactly what we did up above when creating a user went wrong. Then we'll go ahead and send the error back. Right here, .send, sending back the error object. Now that we have this in place, we have that route completely set up. I can save the program and go ahead and test this out. From here, we'll be moving over into Postman to make sure the route's working as expected. I'm going to go ahead and create a brand new request over here for the task app. We'll be setting this one up with a name like update user. Once I save it, the first thing we're going to do is crack it open and switch up the HTTP method. We are going from get over to patch, then we'll provide the URL. Now we are going to need the ID of someone to update. I can always use read users to get a list of all of my users back and pick one that I'd like to change. So right here I have a few different ones. I'll go ahead and grab the ID for this first user. Now I'll go back over to the update user request and complete the URL. That's localhost :3000 /users/ some ID. Now in order to actually set up the updates, we do want to provide the body. So we'll go to body, raw, and we'll switch from text over to JSON like we had done for our two create requests. Right here, we'll be able to provide the JSON describing what exactly we would like to change, and in our case, I'm going to add a last name onto the name. So right here, I will be updating name. I'll go ahead and change it from Andrew over to Andrew Mead. Now, if I go ahead and fire this off, I would expect a 200 status code as the response, with my updated user as the response body. Down below, that is exactly what I end up getting. So right here, I am indeed able to update the user as expected. Now, if we were to swap out that ID with something that did not exist, I would get the 404. And if we were to go back to the ID that was valid, but try to update in an invalid way, I would expect to see that 400. So right here, I have the valid ID once again, and I'll try to set the name equal to nothing, an empty string. When I do that, down below, I get a 400 bad request with my validation error showing up. So here we can see that we are indeed able to update the user as expected. Now, if we tried to update a property that the user didn't have, it would be completely ignored. So right here, the only thing I'm going to try to update is height. Now, height is not something we track for users, though I'll try to set it equal to 72. That would be my height in inches. If I go ahead and send this off, down below, we're going to see our user object, but we're not going to see a height property. So any of those properties that don't exist on the user will be completely ignored. Now you'll notice we're getting a 200. That's because, once again, Mongoose is ignoring them. If you wanted to set up an error response, you would have to add some custom code to get that done. And I'll show you how to do that right now. So let's say we want to send back a 400 when you try to update a property that's not something you can actually change. This would be something like _ID, which you can't update, or something like height, which doesn't exist in the first place. To get this done, the first thing we want to do is figure out what someone should be allowed to update, and we're going to store this in an allowed updates array. Right here, we can list out the individual properties we would like someone to be able to change. This is going to be an array of strings, so I'll allow the updating of name, email, password, and finally age. Everything else will be considered invalid. Next up, we have to figure out what they're trying to update with this operation. Now we know that request.body is an object with all of those updates, but what I want back is an array of strings similar to what I have here, and I'd like to store it on another variable which I'll call updates. Now to get this done, to convert our object into an array of its properties, we'll be using object.keys. Right here, we pass in the object we're trying to work with. So it's going to take this object in, and keys will return an array of strings where each is a property on that object. Now, if I was to use this example data, I would have an array with a single item inside the string height, as that's the only property we're trying to update. Now, the next thing we want to determine is if every single update can be found in allowed updates. If almost all of them are, that's not enough. Every single one needs to exist inside of here. If we're trying to update something that doesn't exist, we'll consider the whole operation a failure. Now to track this, we can use a Boolean is valid operation or something similarly named. And what we're going to do is use an array method you might not have used before. This is every. Now we're going to use it on updates, so it'll be updates.every, which we'll call as a function. Now every, like most of our array methods, takes a callback function as its one and only argument, and this callback function gets called for every item in the array, so for every attempted update. We get access to the individual item right here. So if I'm trying to update 5 properties, this function would get called 5 times with those 5 different property names. Now it's up to us to return true if the update is allowed and false otherwise. So every is going to run your function for every item in the array. If you always get true as the return value, every will return true. If you don't always get true back, every will return false. So if I have 10 trues, then every will return true. If I have 9 trues and a single false, every will return false. Now this is exactly what we want. We're going to return, and we're going to see if the update is included in allowed updates. So allowed updates.includes, which returns a Boolean, true if it's included and false otherwise, and we'll just check if that individual update is found. Right here, we have exactly what we would need. Now we can use the arrow function shorthand, so here we are just returning the following. I can take that, I can remove the curly braces, and I can paste it right here, making sure to have the closing parenthesis, which matches up with the opening one for the every call. Now all we have to do is see what isValid operation exists. What it equals to. So right here, if, and we want to check if it's false. So if it is not a valid operation, we're going to go ahead and stop things by using return. I'll use response.status to send back a 400, and then I can use send to send back an object, and we will set up an error property right here. I could provide an error like the following: invalid updates, excellent. Next up, what is the actual condition? Well, I want to run this code if isValid operation is false. So is valid operation. Now this is only going to run if it's true. In order to reverse that, we use the logical not operator to flip the Boolean from either true to false or false to true. So right here, we have the exact same update logic, but with a little additional error handling, making sure that the user is using the operation correctly. As mentioned, it's not going to impact the functionality. You already weren't able to update properties that didn't exist. The goal here, though, is to provide the user with as much information as possible as to why things aren't going as expected. If I tried to update the height to 72, and I got a success status code, but I didn't see it down below, I could be a little confused. But now if I go ahead and fire off the same operation, I get a 400 with invalid updates showing up, which is fantastic. Now, once again, let's go ahead and try to update something valid and make sure that still works. Right here, I'll try to change the name one more time, and I'll go ahead and change it to Jess. If I fire that off, I do get a 200, and I can see that property updated down below. So there we go. That's how we'll be setting up HTTP routes for updating a given resource. Now, some of our endpoints are going to have logic that's a little more complex than others, and that's okay, because some are indeed simpler than others. In general, the routes for updating resources are the most complex. So here we can see we do have more code in a single express route handler than we've had before. Now that we've done this once together with users, in the next video, it's going to be your challenge to do something similar for tasks. I'm excited to get to that, so let's go ahead and jump right in.